So these first couple equations here are just warm-up problems where we are solving equations that include exponents. So let's just do one of these as a quick start. So taking a look at number 1 here, I have negative 2x to the 6 equals negative 1,458. So my goal is going to be to isolate x. So the first thing I'm going to do is divide out my coefficient. So on my left side here, I have x to the 6th power, which equals, using a calculator, we got 729. Okay, now in order to undo my exponent, I'm going to use a radical. So I'm going to take the 6th root of both sides. That way my exponent cancels out. So this is going to leave me with x equals, remember, if you take an even root, we need plus or minus the 6th root of 729. From here, if I want to simplify my radical, I'm going to take 729 and I'm going to use some prime factorization. So 729, let's see, I can make that 27 times 27. Okay, factoring my 27s, I've got 9 and 3, 3 and 3, and same goes on this side. So in the end, if I'm just looking at my prime factors, I've got 3, 6 total 3's, which works perfectly with my index. So I'm going to rewrite the 6th root of 729 as x equals plus or minus the 6th root of 3 to the 6th power. Okay, now I'm going to simplify, and my index and my exponent are going to cancel, giving me plus or minus 3. So one thing that I would recommend doing whenever you solve any equation is check your answers. So in this case, I need to check if I plug in positive 3 or negative 3, is my equation true? And if you guys check, you will see that it works out perfectly. So we're good to go. Okay, you guys can try these other two on your own. It follows the same exact process, but that is a nice warm-up going into the radical equations. So for radical equations, a radical equation is an equation with radicals that have variables in their radicands. So we can solve them within the set of real numbers. Okay, so the first case that we have here is if the variable is a factor of two terms and is not under a radical. So that would be a case that looks something like this. So in this case, we're going to move the terms with the variable to one side, factor out an x, divide by a coefficient. Then if we need to rationalize the denominator and check our solutions. So let's just do number 1 for an example. So my first goal is to move all of my variables to one side. So I'm going to start by subtracting x to the right side. So that would give me 1 equals x times the square root of 2 minus x. So now my x's are on the right side. Step number 2, let's factor out an x. So that would give me 1 equals, factor out an x. If I factor out an x, my first term here, I'm just going to have the square root of 2. And in my second term here, I'm going to have a negative 1. Now, if I want to solve for x, I just need to divide the part that I factored out from. So let's divide square root of 2 minus 1 and square root of 2 minus 1. Okay, simplifying on my left side here, I'm just going to have a fraction. So I've got 1 over square root of 2 minus 1. On this side, this is going to all cancel out, leaving me with just x. Okay? So obviously, I'm close to solving for x here, but in order to solve for x, I would need to rationalize. So luckily in this case, I have n, I can multiply this by a conjugate. So I'm going to multiply this by square root of 2 plus 1 over the square root of 2 plus 1. That way, all of my radicals are going to cancel out with each other. Okay, multiplying that in my numerator here, I've got square root of 2 plus 1 over, and then in my denominator, I'm going to need a FOIL. So square root of 2 times square root of 2 would give me 2. Square root of 2 times negative 1, negative square root of 2. 1 times the square root of 2 gives me positive square root of 2. 1 times 1 gives me negative 1. And all of that is going to equal x. So as you guys can see, my radicals are going to cancel, leaving me with x equals the square root of 2 plus 1 all over 2 minus 1, which is 1, which ultimately would just simplify to the square root of 2 plus 1. All right? So that is how you are going to solve radical equations if you have a common factor between your two terms and they are not underneath the radical. The second situation that you guys are going to see is if the variable is under the radical. So if the variable is under the radical, you want to isolate the radical, then use an inverse to undo the radical operation, and then finally solve for the variable and check your solutions. Okay, and we really did forget to check our solutions in this first part. Let's go ahead and do that quick. So checking my solutions for this part, I would substitute in the square root of 2 plus 1 into my equation. And as you guys can see, the square root of 2 plus 1 is going to give me the square root of 2 plus 2, which is going to equal the square root of 2 plus 1 times the square root of 2. Square root of 2 times square root of 2 is just going to give me 2 plus the square root of 2 times 1, which is the square root of 2. So ultimately, square root of 2 plus 2 equals the square root of 2 plus 2. We're good to go, so we checked our solution. Okay, going back to case 2 here, let's start by isolating our term with the radical. So let's add 3 to both sides. This is going to give me the square root of 2b plus 2 equals adding the 3 to the other side, which is just going to give me negative 12. Sorry, I think we're going, no, we're good. Okay, so anytime you see that a square root equals a negative, this should instantly be kind of a red flag for us. But let's continue solving and then just make sure to check our solutions in the end. So now, if we want to simplify a radical, let's take both sides and square them. That way, my radical and my exponent are going to cancel. So on my left side, I've got 2b, it's 2, which equals negative 12 squared, negative 12 times negative 12, which is 180. and 44. So now at this point, this is quite an easy equation to solve. Subtract 2 from both sides. That'll give me 2b equals 142. Divide both sides by 2, and that's going to give me b equals 71. I should really be careful here because this looks like 6, 2, b. Okay, let's go ahead and check our solution. So if I plug or substitute 71 into both sides, that's going to give me the square root of 2 times 71. It's 2 minus 3 equals negative 15. And using a calculator, my left side is going to give me 9 equals negative 15. Obviously, this is not a true solution. So ultimately, I'm just going to write no solution. Okay? So it's super important that you guys check your answers every single time you're solving a radical, because no real solution is definitely a possibility. I should really add real in here, because you could find an imaginary solution. All right, case number 3. If there is a variable under 2 separate radicals, you are going to want to separate the radical terms to opposite sides. Then undo the radical operation, isolate the remaining radical term, undo the radical operation, solve for a variable, and check your solutions. So this sounds really complex as of now, but I think the algebra will follow itself. So let's start by separating my radicals. So let's add our square root of 3x to the other side. So that's going to give me square root of x plus 1 equals negative 1 plus square root of 3x. Okay, now I'm going to want to take care of my radicals. So I'm just going to go ahead and square both sides. So squaring my left side here, pretty simple. My radical cancels out with my exponents. But on my right side here, I have multiple terms. So I'm going to have to FOIL. So I'm going to expand this, write it out, and now I'm going to go ahead and FOIL. So this gives me x plus 1 equals plus 3. Obviously, this doesn't fully simplify. So let's just rewrite this as x plus 1 equals, oh, sorry, this should have been a 3x, my bad. Square root of 3x times square root of 3x. So this gives me 1 minus 2 square roots of 3x plus 3x. And now we're just going to go ahead and solve for x. So I'm going to start by subtracting 1 to my left side and subtracting my 3x to my left side as well. So subtracting my 1, that's going to give me, 1s are going to cancel. X minus 3x gives me negative 2x equals negative 2 times the square root of 3x. Now I'm going to divide both sides by negative 2. Which is just going to leave me with x equals the square root of 3x. Now I'm going to want to take care of this radical. So let's square both sides again. So x squared is just x squared. And on my right side here, my radical is going to cancel, leaving me with just 3x. Now I'm going to subtract 3x to the other side. So that gives me x squared minus 3x equals 0. All right, now I have a quadratic. So I'm going to have to solve by factoring. So looking at this, I can see right away that I have a greatest common factor of x. So let's factor that out. So factoring out an x, that leaves me with x minus 3, which equals 0. And now I'm going to set both of my factors equal to 0. So out here, I've just got x equals 0. And then over here, I have x minus 3 equals 0. Subtract or add 3 to both sides, and that's going to give me x equals 3. Okay, so now I have found two different solutions for my equation. So now I'm going to substitute both of those into my initial equation up here and check my solutions. So checking x equals 0, if I was to substitute that in, I would get 1 equals negative 1. This is not a true statement, so no, x equals 0 is not a solution. If I was to substitute x equals 3 into my equation, I would get negative 1 is equal to negative 1. So yes, x equals 3 be a solution to my equation. All right, so that is just one run through of the cases. I do plan to do one more of each of the cases in class together. So hopefully if you have any questions, we can clear it up then. It is a lot of different algebra, and it's just important that we are following the correct steps depending on the type of situation that we have. All right, thanks for watching. Bring any questions you have to class.